Hi friends, I am Shravana and welcome back to my channel Sparkling Future. Before starting with today's topic, I request all of you to subscribe to my channel and also please like, share, comment and hit the bell icon for the latest video notifications. Thank you. Friends, in the previous video we have discussed about partitioning and bucketing, like what are the differences and when to use which option in Hive. Okay, in continuation to that video, today we will see how exactly these things will perform in MapReduce and Spark. Okay, so in the previous video we have created a table for partition table and then bucketed table. Now let's consider an example scenario where we have one Hive table with a partitioning and a date column. Okay, so let's consider this sample query only. So when you run this query, then what will happen is it's a simple select statement, right? So what exactly will happen when you run the MapReduce, right? When you run this Hive in hrefs directly like Hive shell. So as we all know, first it will apply partition pruning. So what is this that partition pruning is? It will identify the relevant partitions based on the partition column which is available in this where condition, and Hive will know that which specific date needs to be processed. And if we are mentioning the bucket also, right, if it's a bucketed table, then and also if there is a where condition available for that particular uh, where condition, right, then Hive will determine that only that particular bucket data needs to be processed. Now let's take that we have that and condition as well, and something like product, let's say product equal to something called a. Okay, let's say this is for example. Now when you execute this query, right, so this MapReduce will perform this partition pruning and then bucketed pruning, and then it will generate the tasks. So how these tasks will be generated is, here I am giving the example. Okay, this is an example, and of course it varies based on the dates, the size of the data that you have, the execution engine configuration, and the way the query. Okay, this is mainly about the query. So now uh, as we saw, right, here we have three examples. Hope you remember in the other day we created one table with three partitions. So let's take the same example. So let's say we have three partitions, date partition 7 July 1st, 2nd and 3rd. Okay, and then we have, let's say, four buckets. Just for simplicity I am taking that. Okay, now these are the tasks will be generated. This is also, let's assume, as I said, these will be based on various things like the size of the data, the configuration, the query, the usage of the query also, like what kind of where conditions that you have in the query. So MapReduce will generate these tasks. Okay, like what is the partition that it needs to be read, and what is the bucket. Okay, so let's say we have three partitions and six buckets, let's say, because we have three partitions, right? I'm just taking it. So now this way it will create the six tasks in MapReduce. Okay, so this is how the task will be created in MapReduce. And if you see, if you execute the same query in Hive also, almost the similar kind of tasks will be created even from Spark, because you don't usually see significant number of tasks difference of the number of tasks between MR and Spark. But where exactly the difference comes is the execution engine. Okay, now let's look at this one. See, this is the MapReduce execution flow. So what will happen in this flow is, whatever query that you are triggering, this Hive query will be sent to the MapReduce for execution. And then this MapReduce performs partition pruning and bucket pruning. If it has, then it performs the task generation. We have seen, right, how the tasks will be generated. Similarly, the task will be generated. Okay, so if you see here, there are task 1 with the first partition and first bucket, second part the same partition for the second bucket. Okay, and again the second partition, first bucket, and second partition, second bucket. So this way it will create, it will split the tasks. Okay, now after that task generation, which this is the main concepts of the MapReduce is map phase and reduce phase. So this is where the query will be sent in the mappers, and then mappers will be generated, the input splits will be generated, and then the results will be sent to the reduce. It what to say, it performs this reduce operations, and finally the final result will be sent back to the driver. So this is the way map reduce executes the Hive query. Now coming to the Spark, right? What the same query, if you execute the Spark, the same kind of execution that we see, right? The same query will be sent to the Spark execution. It does partition pruning and bucketed pruning, and the tasks will be generated. Till here the procedure is same. We have seen, right? Even the task also, I mean, in most of the cases there won't be significant difference in the number of tasks if giving that Spark is underlying HDFS, and then as I said, right, it's not complex query, and based on the data, everything. And then this is where the concept, the Spark concept comes into the picture, which will give us the potential time benefits when compared to MapReduce. Why? Because Spark gives us the in-memory processing, which will be like intermediate cache will be generated. Because of that, the results and then the query execution will be faster. And we have the data locality concept. The data locality is also available in Hadoop, but it comes to the in-memory processing, it will be much more faster in Spark. And after in-memory processing data locality also, this particular query goes to the catalyst optimizer, which will give us the uh, optimal plan with which using which we can perform this query in very lesser time, and we get very potential time benefits here because of this optimizer. And then AQE, which is adaptive query execution. There is a detailed video on what is adaptive query execution. You can go through that and then understand, but this is the best optimization technique provided by Spark for improving the performance. After performing all this, the query, the final result will be sent back to the driver. Okay, so this is how the MapReduce will execute the Hive query, and Spark executes the Hive query. So now what is the conclusion that I am trying to make is, when you query Hive in Spark, we get lot of benefits. And in the next video we will dig into a bit deeper to see what all components will be participated in Spark when you execute a Hive query from Spark. Okay, hope this video is useful to you, friends. Thank you for watching the video. Please subscribe to my channel for more interesting learnings. Thank you.